Okay. All right, here we go. So today's topic of discussion, we're going into sequences. Sequences will take us a week to cover. It's all about patterns. Describe the pattern that's formed. You got questions. We got numbers 1, 2, and 3. Let's tackle this first one. Does anybody see a pattern here for this first one? Yeah, that's it. Look, -5. Let's see again. Up, -5. Ooh, one more time. Yeah, -5. So the pattern that we're seeing is subtract 5. Could you do me a favor? Could you I don't know, maybe find the next 3 terms in this sequence, and what would they be? Yeah, 18, and 18 minus 5 is 13, and 13 minus 5 is what? Good. Yep, that's how it works. Alicia, what's going down here? Yeah, it's doubling up. So it's like times by 2, times by 2, times by 2. So we would describe that as what? Double each time? Sure. And then let's do B. Let's do B. What's the next one? 112. Anybody remember that group? What about this one? 224, and then what? 448. Yeah, the last one. The last one, let's see, we're going to go with, we'll do it in black. This is +2, and then we got +4, and then we got +6. So it's all, there's nothing more than us just picking it out. Some people are just naturally good at it. And sure, I would say multiples of 2. But you could say something else if you wanted to. You know, you might have a different description than me. And then what would the next term be? Let's see. It's going to be 37 because the next time I'd be adding 8. And then I got to. Very nice. Great job, guys. Great job. Yep. 2, double each time, subtract 5. Okay, great. Great thoughts. So we're up to explicitly defining a sequence. Guys, what's the word explicit mean for you? Bad words, right? What? For me, explicit, that means straightforward, right? Yeah, you could make bad words, but it means like you're not sugarcoating anything, right? It's just very, very, very straightforward. Okay. So explicitly defining a formula, explicitly defining a sequence. Well, what are we going to do here? We have to basically build a formula that creates this sequence. Most often, this is given as a multiple choice question where they just give you the sequence and you have to pick the answer, pick the formula that builds it. But we're going to try and do it by hand right now. So here's what I'll tell you. Let me give you a few hints along the way here. Do you see this 7 right here? I'm going to call that A1 because that's the first term. And this right here is going to be, guess what? A2. What about this one? A3, A4, A5. So people in the other class have asked, they said, well, what is this fancy looking QA business over here? In part B, I'm asking you to find the 20th term. It matters how you write this. You have to use subscript. In other words, the A has to be below the line, small and little. Hold on one sec. We got to build a formula out. Now we're going to use the same process that we did in the other, that we did on the first page. We're going to try and figure out what's the pattern going on here. How do we get from term to term? Yeah, they're multiples of 7. Very nice. So we're going to add 7 to each time. There we go. And so here's what an explicit formula looks like. What you do is you say a to the n, any number you want in the sequence, or any term, equals. Now, how do you build this sequence? What's the formula? Yeah, great suggestion. It's just going to be 7 times the number you're looking for. What do I mean? A lot of this is guess and check, by the way. How do you do this? Some people are just naturally better at it than others. Whenever you perform this, you need to check it. Let's make sure it works. So let's see. What's the first term of this sequence? It's got to fit in our formula. 7 times 1. Did it work? Oh, yeah. Let's see if the second term works. Did it work? Should we see the third term, or you believe me? Okay, good. All right. Let's do part B. Let's do part B. A to the 20th. A to the 20th is simply just going to be 7 times 20. And so the 20th term of this sequence is 140. Hold on one sec. So we're going to do the same thing as before. Let's label up our terms so we always get them straight. You know, A2, A3, this is the third term. This is the fourth term. This is the fifth term. And now let's see if we can see a pattern. Alicia, what'd you say? What's going on over here? Yeah, we're adding 2 to each one. But it's tricky how you build the formula for explicit, how you build an explicit formula. Well, explicit formulas always start out like this, a to the n. And so now, Alicia, what do you think it is? A plus 2. Let's see. A plus 2. Always we got to do a little check. Let's see if it works. Okay? So a to the first equals 2. Oh, I'm sorry. Yeah. A to the first equals 1 plus 2. And that one works, so you get 3. But let's see if it works for the second one, too. 2 plus 2 equals 4. I know you realized your mistake. I just wanted to clarify that you can't just use it on the first one. You got to keep going. So this actually won't work. Any ideas? Bill? You're the man. I don't know how you figured that out. Bill, how did you figure it out? Guess and check. Is there any like particular strategy thing that you took? That's cool. Sometimes it's just luck. Let's check to make sure it works. Yep, that one worked. Let's see if it works again. Ah, it worked again. Should we try a third time, or you believe it works? Okay. All right. Let's go use our formula to find the 20th term. So it's going to be 2 times 20 plus 1. And so the 20th term is 41. So sometimes they don't even give you the sequence of numbers. Sometimes they just give you the formula outright, the explicit formula. And they say, do me a favor, go find the first 3 terms. How do you do that? Just plug it in, plug it in. So here you go. Here's the answer. We just plugged in. The first 3 terms of this sequence are 1, 3, and 5. All right? Let's have a go at this one. All right. There you go. And there's the answer. Piece of cake. All we're doing is plugging in. So recursive formulas define the sequence by taking a number, and you need that number to find the number in front. This is different than explicitly defining a sequence, because when you explicitly define a sequence, you're given a formula, and it builds every number there afterwards. What do I mean? This is an example of a recursive formula. And the question wants you to find the first 4 terms. What's the first term of the sequence? What's up? What's the first term? Nah, the first term they give to you. The first term is -4. Okay? Now, how do you find the second term of this sequence? All you have to do is use this formula over here and plug in. You see how I plugged a 2 in for the n? Okay, so we're just going to do that again. A, 2 minus 1. hold on, that's really annoying, plus 5. So a 2 minus 1, a sub 2 minus 1, 2 minus 1 is 1. So basically what this formula says is that the next term of this sequence, you take the first term that you got and you add 5 to it. So we get negative 4 plus 5, which is negative 1. Maybe I'll show it to you like this to make it easier. I'll show it to you. Oh, I'm sorry. Sorry about that. This should have been 1. Let's go and find the next term of this sequence. I'm going to use a different color. A sub 3 equals a to the 3 minus 1 plus 5, which equals a to the second, a sub 2, in other words, the second term of this sequence plus 5. What was the second term of this sequence? Good. Plus 5, and that equals 6. And if you're real smart, you can start to see the pattern emerging. Let's find this last term. Red, green. Let's go with blue. The fourth term of this sequence is a to the 4 minus 1 plus 5, which equals a sub 3 plus 5, which ends up equaling 6 plus 5, which equals 11. And that's how we do it.